Good afternoon. I'm going to present very briefly on the preliminary study that I did on climate extremes with focus on cold snaps. And the contents are what is interesting about it, the study so far about its occurrence, how it can be modeled, and the expected outcome of the research. So extremes may does not have a unique definition or quantitative value for a particular rain, heat, or temperature event. In a sense that a very rare occurrence of cyclone, if it happens in the middle of the ocean and does not cause any damage, then it is not counted. But similarly, depending upon the impact on society, normal occurrences can also be termed as extremes. So depending upon the place and time, an event is classified as an extreme event. The first few slides here, I'm showing how unusual cold weather is affecting us since the last 2 decades. Here is the data from Indian Meteorological Department showing that for the same year, there are more casualties from cold than from heat for certain years. We are also aware of the cold during the last couple of years, making news headlines as unprecedented events in the northern India. Now, also climate phenomenon like the Pacific decadal oscillation, although this is not the only one phenomenon, which lasts up to 20 to 30 years, is a mode of variability of the Pacific climate, occurs in the northern Pacific Ocean, unlike ENSO, may attribute to the short-term temperature variations in a generally warming climate. While PDO's primary signature is more significant in the North Pacific or North American countries. Its secondary signature may exist in the tropics. Why it is interesting in the current context of climate variability is that it has been reported that inserting a PDO pattern into the global climate models causes decade scale breaks in global warming. Now, here is a picture from the Midwest of USA showing the severity of the cold winter during the last year. And there has been studies linking this kind of cold extremes from in the several past years to the weakening of the polar vortex. Now here in the picture on the right, I'm showing that the in case of a stable polar vortex, the strong cold jet streams are following their usual path in the anti-clockwise direction and confining the cold in the polar regions. But jet streams become weaker due to some reasons, and polar vortex spreads in wave encompassing the mid latitudes, contributing to cold. And here in a paper by Jennifer van Francis, she has linked the melting of Arctic ice to the polar vortex as well. Now here another paper, another picture from the Delhi winter, smog-filled winter morning is shown. And although the temperature in Delhi does not fall below the 0 degree centigrade, but living standards of majority of population is not designed in a way to tolerate very sharp drop in temperature. So it can negatively impact people and places and infrastructures and ecological parameters and agriculture, etc. Now it is important for the scientific community to come up with a strong rationality for observed extremes, because it not only is counterintuitive for the general public to expect severe cold in a warming climate, but also to be able to convince policymakers about the possible outcomes of temperature, precipitation, drought, or storm due to global warming itself. Now, earlier studies also mentioned that outbreak and transmission of certain pathogens have become more prominent in winter and dry conditions. Although the ongoing pandemic, it is not showing a very, it is not showing such trends. But it has been established earlier that flu and influenza like outbreaks occur more during the winter or in the cold regions during the cold temperatures. So also there are certain places in the mid European countries where human vulnerability is more high to cold weather, or where snow water equivalent is critical for water resources planning. So in these regions, cold extremes are supposed to have significant impact. Now, the studies conducted so far is just a brief description of the results from the 2 3 papers that I have read before 1 month ago, actually. So this is one paper where it is persisting cold extremes under 21st century warming scenarios. And here what they have done is they have taken 3 indices: the cold extreme intensity, the cold extreme duration, and cold extreme frequency. Intensity they have measured as the average daily maximum temperature for 3 consecutive days in the year, when this 3 maximum has the lowest value over the year. Then similarly, cold extreme duration, they have measured as the annual maximum of consecutive frost days, consecutive, when the minimum night temperature falls below 0 degrees centigrade. And the frequency is the total number of frost days. So here they have measured this grid-based intensity duration frequency of cold extreme events from this 9 IPCC AR4 multi-model models, and for the decades of 2091 to 2100, and compared it with the decade of 1991 to 2000 of historical data. For they have not considered historical data here, but they have considered NCP and CAR reanalysis data for comparison. And they have found the following results: that intensity and duration of cold extremes may persist at the end of the 20th century, and frequency but though have decreased, but it has become more intense. And in many situations, the bounds on these multimodal projections may be at least important for regional preparedness efforts, like these bounds that they have collected from the 9 separately conducted, separately run models. They have extracted the central tendency, the lower bound, and the upper bound. And they have shown that although the lower bound does not show quite persistence, but as the bounds appear large, the maximum bound shows the widespread persistence. Now, this is another paper. This paper was published for the purpose of refuting the claims that global warming is a hoax, which became quite popular in the end of the first decade of the 21st century. And this figure here, it shows an individual simulation of the ACAM5 coupled with climate model of symmetry forced with CRS A2 scenario, and the highlighted periods show statistically insignificant negative trends based on simple regression, simple least square trend line. Now, to show that this behavior is not unique to ACAM5 models, probability distributions of decadal trends in annual air surface temperature in observed records and other experiments, they have also compared. So, and these observed simulations show a very similar distribution to the 20th century simulations, and giving credence to the conclusions in the assessment report 4 of the IPCC basically. So, but this paper, this is another paper again, which looks into the one of the hottest places on earth, the Lut Desert, also known as Dasht-e-Lut in Iran. And the purpose of this analysis is to understand the land atmosphere interactions in extremely hot environment and see if it offers any insight on how interactions will change on a warmer world. Now, land surface temperature is a key variable for understanding such interactions, as they have said. And using this improved MODIS data for LST, it was found that maximum temperature was recorded as 80 degrees centigrade, which is 10 degrees higher than a previously recorded value. Then they have also found that the range of diurnal variation can go up to a maximum of 71 degrees centigrade. There is also something interesting to note in this desert region is that it has more than 30% Virga precipitation, that is precipitation that evaporates before reaching the ground but is recorded by satellite-based estimates. Now, despite harsh climate, it is also interesting to note that it sustains incredible biodiversity of many kinds of wildlife. Although in winter 50% of the data were missing because LST products are often influenced by clouds and other atmospheric disturbances, they used another product of MODIS, aquathermal anomalies, and fire daily to mask the LST pixels with fire. However, only 10% data was missing for the summer when maximum temperature occurs in the Lut region. And trend analysis, removing annual seasonality, shows maximum and minimum temperatures are increasing in the region at the rate of 0.4 centigrade per decade and 0.62 centigrade per decade respectively. This is another review paper discussing the link between the snow cover on Tibetan Plateau and subsequent weather and climate systems. Now here is a picture of the Tibetan Plateau, and it is 400,000 meters above the sea level and has highest cryospheric extent right after the poles. So it is also referred to as the third pole. And so it becomes very important with relation to the weather system in India also, the study of this and the whatever climate phenomenon goes on inside this Tibetan Plateau is important with respect to with respect to the Indian summer monsoon as well. So it is also referred, so it's the important properties of snow are high emissivity, high albedo, and low thermal conductivity. So all these properties also are responsible for the temperature or for the weather of this particular region, for the climate of this particular region. Now here over 100 meteorological stations are there over the eastern part of the plateau, and towards the higher complex terrains there is not much weather stations that can cause the um, disparity or some lack of understanding of the phenomenons that is going on in this place. Now here also this is a picture of the dominant circulations, which may or may not have any correlations with the snow cover or snowfall intensity over the Tibetan plateau, and it has been actually discussed in detail. Now this is the flowchart of the datasets, mechanisms, and consequences and perspectives of the entire like observations, reanalysis data, whatever has been used in short. And these are the quick points that I have extracted from this paper, that snow is poorly simulated by most CMIP 5 GCMs due to limitations in parameterization schemes, understanding of localized convections, leading to overestimation of snow cover in complex terrain. Then global mean was found to be warming at 0.85 degrees centigrade during the 1880 and 2012, whereas over from 1961 to 2030, 0.3 degrees centigrade per decade over the TP has been set to increase over the Tibetan plateau only. Now, there is no widespread decline in snow cover over the Tibetan plateau in the last 15 years based on Modi's data. Then also it is also difficult to determine the relative contribution of the above mentioned factors in controlling the variability of the snow cover over the Tibetan plateau. And these are some of the questions that can be looked into. Are existing observations sufficient to underpin the assessment of extremes? What are the contributors to observed extreme events and to changes in frequency and intensity of the observed extremes? And what are the roles of large-scale regional processes as well as their interactions for the formation of extremes? And are models able to reliably simulate extremes and the changes, and how this can be evaluated and improved? This is a picture of the actually here. I wanted to see how CMIP 5 is different from CMIP 6, and so here the difference is that it's a combination of like shared socioeconomic pathways and RCPs, and it represents in a combination in an integrated scenario of future climate and societal change, as long as the combinations are feasible. So it's basically the same thing. Then on how it can be, regarding how it can be modeled, these are the important considerations that I have found and extracted from the papers that I read along, that both short-time and long-term extreme weather event predictions are important. A better understanding of the drivers and processes will improve the prediction of extremes and will support process-based evaluation of the presentation of weather and climate extremes in climate model simulations. And the development of extreme event also depends upon favorable initial state and presence of large scale drivers and positive feedbacks. And these are a few points collected from the paper, recent paper, how CMIP 6 is more advantageous over CMIP 5 in terms of Indian summer monsoon rainfall simulations. And this is the expected outcome of the research. This is the immediate plan, which and I will discuss further in the group meeting. Thank you.